have Fe, which is half times F, 50. Extension now is what? 4, which is equal to 2 here 1, 2 here 2. 2 times 50, 100 joule. 100 joule. And that is the energy stored in the spring. Consider new topic right now, and the topic is gravitational fields. Under this topic, the candidates are expected to know the following: identify the expression for gravitational force between two bodies. So also the candidates should be able to apply Newton's law of universal gravitation. They should be able to give examples of conservative and non-conservative fields. The candidate should be able to deduce the expression for gravitational field potentials. At the same time, they should be able to identify the causes of variation of G, that is, the acceleration due to gravity on the Earth's surface. And they should be able to differentiate between mass and weight. Finally, being able to determine the escape velocity. Before we go to the calculation we have under this topic, we are going to look at the summary of what a gravitational field is all about. A gravitational field is a region or space around a mass in which the gravitational force of the mass can be felt. And that is the understanding you have, the basic understanding about the gravitational field. A region or space around a mass, let's say mass m, in which the gravitational force of the mass can be felt. At the same time, gravitational force of attraction exists between a mass and all other masses around it. You have to take note of that. Then at the same time, we are going to consider a Newton's law of universal gravitation, because that is what we want to base our calculation upon. Newton's law of universal gravitation states the gravitational force of attraction between any two masses, let's say mass m1 and m2, and that same gravitational force is directly proportional to the product of the masses and inversely proportional to the square of the distance between the two masses, and that is the Newton's law of universal gravitation. This can be stated symbolically or mathematically. For Newton's law of universal gravitation, the force F is directly proportional to the two masses m1, m2, and the same force is directly proportional, inversely proportional to the distance between the two masses. If we try to join these two together, this is what you are going to have. Then if we try to change this sign of proportionality, we are going to have, we change it to equality sign, then we introduce a constant, and the constant here is our capital letter G, which we call a gravitational constant, which is equal to R squared. And this value G, which is a gravitational constant, it has a constant value which is 6.67 times 10 to the power minus 11. And it has the units. You can get the units from here. Let's try and make G the solid of the formula. From this, let's call this one equation 1. let's say from equation 1, let's make our G, which is our gravitational constant, the subject of the formula. We are going to have G is equal to G m1, m2, everything equal to F whole squared. So that G is equal to F whole squared divided by m1, m2. Let's look at the unit of force is Newton. This is a distance, a radius. And the unit for distance is meter. Meter squared, all divided by, this is mass. And the mass is kilogram. That one will give us kg squared. If you try to put it normally, you are going to have Newton meter squared. When this one goes up, we have per. So this is now the units of our G, which is gravitational constant. So we are going to have the basic value for this G is 6.67 times 10 to the power minus 11 Newton meter squared per kilogram squared. And that is the unit. Then we can use this expression to solve questions. But before we go into that, we are still going to consider what we call escape velocity. Escape velocity is the maximum velocity required for an object to just escape from the gravitational influence of the Earth. Is the maximum velocity that is being required for an object to just escape from the gravitational influence of the Earth. And the escape velocity, mathematically, VE, escape velocity, is equal to square root 2 g/r. Here, our small r is what we call the radius of the Earth. The radius of the Earth. Your small g is still your acceleration due to gravity. And now we are moving to solution to some questions we are having with us. Let's consider question number 1. The question number 1 says two spheres of masses 5.0 kilogram and 10.0 kilogram are 0.3 meter apart. Calculate the force of attraction between them. This is year 2007. Two spheres. We are given the masses of mass 5 kilogram. Let our M2, the second mass, which is 10 kilogram. Then we are given the distance between the two masses, which is your radius, and that is 0.3 meter. We are to calculate the force of attraction between them. We are going to have J M1 M2 over R squared. This is what we are going to use. From the equation, we have been given the value of G, that our G is 6.67 times 10 raised to the power minus 11. So the question is simple. Let's quickly substitute the value that we have. Our M1, our G is 6.67 times 10 raised to the power minus 11 times M1, which is 5, times M2, which is 10, all divided by 0.3, but we have squared. We put squared on the top of it. So this is what we are going to. So we are going to have 6.67 times 10 raised to the power minus 11 times, this is 50, all divided by 0.3 squared. And 0.3 squared should give us 0.9. Okay? So from there, we are going to try and evaluate this to use what we are having here. We are going to have 6.67 multiplied by 50. What we are having here is 3.5 all times 10 is to the power minus 11 divided by 0.9. To evaluate it further, let's try and divide 3.5 by 0.9. What are we having? Divided by 0.9, we have 370.555 times 10 to the power minus 11. Then, what can we derive from there? You can easily say this is equal to 370.56 times 10 minus 11. We are calculating for force, which is going to be what? Newton. That is the force of attraction between the two masses. Question number 2. If the radius of the Earth is 6.4 times 10 raised to the power 6 meter, the escape velocity of the satellites from the Earth is, we have to take G to be equal to 10 meter per second squared. If the radius of the Earth is equal to, we are given the value 6.4 times 10 raised to the power 6. And we are given the value of G to be 10 meter per second squared. So what will now be the escape velocity, VE? And mathematically, the escape velocity is given to G half, the square root, which is equal to 2 times 10 times our radius 6.4 times 10 raised to the power 6, all in square roots. This is equal to 2 times 10 is 20 times 6.4 times 10 raised to the power 6. And we can try and evaluate what will be the value of 20 times 6.4. 6.4, we are going to have 128 times 10.